Hi everyone, my name is ECK from FKE Today we will continue to talk about the Coulomb's law. So today I'm going to show you the solutions of the questions in the assessments. And after that, I will introduce you all the principles of superpositions, how it can be used to find the total force acting on the charge. Imagine if there are multiple of charges surround the charge. Alright, let's look at these assessment questions that I gave you earlier. So we have a 2-point charge. Okay, so Q1 and also Q2. Okay, they are placed in a vacuum, okay, at the following coordinate. So for the Q1, it is a positive charge because there is a positive sign here. Okay, and for the Q2, it is negative charge. Okay, because there is a negative sign there, and they are placed in a vacuum. So vacuum is a free space, so the permittivity is equals to epsilon naught. Okay, so the coordinate of the Q1 and Q2 is this. Okay, so you are required to find the force of Q1 acting on Q2. Oh no, you are required to find the force acting on Q2, okay, because of Q1. Okay, so this Q1 charge apply a force on the Q2. So you are required to find the F12. Okay, so the notations must be clear, F12. So what's the formula for F12 for the force calculations? So you can write out for F12, it is equals to Q1 multiply Q2, the magnitude of both charges, divide with 4 pi epsilon naught. Okay, epsilon naught represent the permittivity of the free space, and you have R12 square. This is the distance between the Q1 and Q2, and this is the distance vectors, unit vectors. Okay, this is a unit vector R12 showing the directions of F12. Okay, so let's see what we have. Okay, so we already have this Q1 value, right? Okay, and Q2 value, and these they are constant, so you are required to find this. Okay, unit vectors and also the distance. Okay, so before we find these unit vectors and also the distance, the first thing that we have to find is this FR12. Okay, this is the vectors, distance vectors, okay, from 1 to 2. Okay, so you are going to take the position vector Q2, okay, minus the positions vector of Q1. Okay, so it will be -1, 2, 6, minus 2, -1, and 3. Okay, so these are the positions vectors of Q2 minus the position vector of Q1. Okay, so you can calculate. I'm using this bracket to represent that these are the vectors. Okay, so it is -3, 2 minus will be 3, and it is 3. Okay, so this is the distance vectors. So from the distance vectors, you can easily find the magnitude, right? So the magnitude is you taking the -3. Okay, so you can calculate them. So it is 27 square root 27. Okay, so to find these unit vectors R12, okay, you're going to apply the formula R12 over magnitude of R12. Okay, so make sure you understand what's the meaning of this, what's the symbol represent this one, what is the symbol mean, yeah? Okay, so you have learned this in multivariable calculus. Okay, so we are going to put this one here, -3, 3, and 3 over 27. Again, I repeat, this one is not okay, representing a coordinate. This is representing that it is a vectors. Whatever inside is a vectors. Vector representations. Okay, IJK. But we don't use IJK in this subject. We use the XYZ. Okay, XYZ. So you got all this already. So you need to pump into your formula for the for the F12. Okay, so what's the value? Is 5 micro and negative 3 micro. Okay, 5 micro multiply with negative 3 micro. You have to insert a negative because this one is it represents that this is a negative charge. Okay, then you have a square root 27 and then you square it, and then you have this negative 3 and 3 over square root 27. Okay, so you can start calculating for the force. Okay, calculating for the force. Alright, so it is negative 0.91 and milli. Okay, this no milli, sorry, micro. Okay, or we can write it as negative 0.96 milli. Okay, milli, and multiply with negative 3 and 3. Okay, so it will be negative positive 2.88. Okay, and then negative 2.88, and then negative 2.88. Okay, I have to use this bracket. Okay, millinewton. Okay, millinewtons. So if you want to write it in proper way, you can write it as 2.88 unit vector x, okay, minus 2.88 unit vector y minus 2.88 unit vector z, millinewton. Okay, as I told you, this one representing that this parameter F12 is a vector. So vector will have directions. Okay, this is the force F12. So if you want to illustrate the force in a diagram, you can draw it. Okay, so let's draw it. So now let me draw this 3D coordinate systems. So first of all, we have to locate the coordinate of the point. So the first point Q1 is located at 2, -1, 3. Okay, 2, -1, 3. So somewhere here. Okay, 2, -1. So -1 somewhere here. Okay, 2, -1, 3. Okay, going up. Okay, so this is the positions of Q1. Okay, -1. Just imagine I extend it. Okay, and then for the Q2, it is at -1, 2, 6. -1. Okay, -1. 2 is here. Okay, so you can extend it. Okay, somewhere here. Okay, and 6 going up. Okay, going up. So this one represents the positions of Q2, right? Q2. Okay, now you are finding the F12, right? You are finding the F12. This is your F12. Okay, charge 1 adding force to 2. Okay, so the directions of your force will be a straight line that actually connecting these two charge. Okay, so this already defined in the Coulomb's law. The force will be acting along the line that joining two charge. Okay, so this one will be your F12. Okay, right. Okay, so this is how you draw the force in the diagram. Now, let's consider another situations. Okay, we'll be using this diagram. Okay, we'll be using this diagram. Okay, so now imagine if there is an additional charge, extra charge. I will name it as Q3. Okay, this Q3. Where is this Q3? Okay, now I want to talk about additional one more charge, and this Q3 is located at 2. Let me see. It's located at 2, 2, 0. Okay, so this is the positions of the new charge. Okay, I'm going to introduce a new charge. Okay, that is at the position 2, and just now we have 2 here also, right? 0. Okay, so there is no up and down. Okay, so this is the position of the Q3. Okay, I talk about a charge, additional charge, huh? And now I'm asking you again, what is the F12? Sorry, not F12. What is the total force that is acting on the Q2? Okay, so this F12 showing that, okay, F1 giving force to Q2, right? So now I give you a new Q3 and I'm asking you, what is the total force that is acting to the Q2? Okay, so now the situation is when you top up with the new charge, huh? So this new charge will give force to the Q2 also. Okay, give force to the Q2 also. Okay, so in order to find this force acting on the charge Q2, we have to find F12, okay, which we already get it just now, and add it with F32. Okay, because now there are 2 charges adding force to the Q2. Okay, so you will have 2 sources of force. Okay, contribute to the total force acting on the Q1. Sorry, adding on the Q2. Okay, and this is F32 representing that this Q3, okay, giving force to the Q2, just like what I show in the diagram. So this is your F32. Okay, clear? So we use this concept, okay, to find out the force that is acting on the Q2. That is the superpositions. Okay, concept to find the force adding to the Q2. So now, okay, in order to apply this superpositions principle, we need to find out, okay, what is the F32. Okay, so the procedure to find the F32 is similar as what we performed just now to find the F12. Okay, for sure we must have the magnitudes of Q3 and multiply with the Q2. Okay, we are not dealing with the Q1 anymore because now it happened between 3 and 2. Okay, so 4 pi epsilon naught, okay, R32 square and unit vector R32. Okay, so let us assume now, okay, the Q3 is equals to 4, okay, 4 microcoulombs is a positive charge. Okay, it's a positive charge, okay, so we will apply this here, okay, later on. Okay, but first of all we need to find out this. Okay, so we repeat again, finding the 3, 2. Okay, so taking the positions of Q2 just now is -1, 2, 6, -1, 2, 6, minus the positions of Q3, which is 2, 2, 0. Okay, so you get this distant vectors -3, 0, 6, and the magnitude is 9, okay, plus 0 plus 36. Okay, I square them. So it is square root 45. Okay, square root 45. And this unit vector R32 is equals to -3, 0, 6 over square root 45. Okay, square root 45. Now we replace it to our formula F32. Okay, so just now I mentioned this is 4 micro. And for the Q2 is -3 micro, right? Am I right? -3 micro, yes. Okay, 3 micro over 4 pi epsilon naught. Okay, and you have square root 45 square. And then you have -3, 0, 6 over square root 45. Okay, so please calculate this. So I think I will calculate this part first. Okay, just combine them. Okay, calculate this part. Then I will multiply it. Okay, one by one. Okay, because they are vectors. Okay, you cannot add them together. You have to multiply whatever value that you get here. Okay, to each terms in the distant vectors. Okay, you should know how to do the multiplications. Yeah? We have done this before. Okay, so this is negative 0.36. Okay, it's a milli, yeah, milli, and you have to multiply with -3, 0, and 6. So multiply -3, so you get 1.07 milli. Okay, this is milli, and you get 0 here. And then for this one, you get -2.14 milli. Okay, millinewton. Okay, so this is the F32. Now you want to find the force acting on the charge Q2. It will be F12. Add up together with the F32. Okay, so what is our F12? We have this is positive, negative, and negative. Milli, okay, it's millinewtons. And for the F32 is also milli, so I will just note it first. 14, okay, so the total will be 0.7 is 3.95, okay, for the X, and -2.88 for the Y, and for the Z is 2.14. Okay, just minus, you get -5.02 and millinewton. Okay, millinewton. So the unit of the force is newtons. So you can write it as 5x. Okay, this represents the x vectors, and this represents the y vectors, and this represents the z vectors. Okay, so you must be able to differentiate what's the difference between these and these. All right, okay, why sometimes I will write in this way, sometimes I write in this way. Okay, they are actually the same, but make sure the bracket that you use is correct. Okay, this one is like a short form, okay, because I don't need to write x and y and z. It will make my calculations to be very long. Okay, so you can choose to apply this one. Okay, but it is the same. Okay, so this is to how you find the total force acting on the Q2 by using the principle of superpositions. Okay? So if you have more charges, you might top out more charges. F3, no, sorry. So it might be F42, for example. Okay, if you have more charges, F52, for example. Okay? Add up continuously until you find the F2. Okay, this is the principle of superpositions.